question 1. Grass clippings are placed in a bin where they decompose. For the time being between 0 and 30, the amount of grass clippings remaining in the bin is modeled by A of t equals 6.687 times 0.931 raised to the t, where A of t is measured in pounds and t is measured in days. For part A, it says to find the average rate of change of A of t over the interval 0 to 30 and indicate units of measure. Okay, average rate of change is really just the same thing as slope, so we would like to find the slope or the derivative of A. So really we are just looking for A prime of, oh no, we're not looking for, we're looking for the slope, and we don't have the derivative, so we can't really do that. It's an average rate, not an instantaneous, sorry about that. So anyway, what we are going to do, we're going to find A of 30, and then we'll subtract A of 0, because that would be like your y2 minus your y1 all over x2 minus x1. And when you do that, you should get negative 0.197 as your answer, and it does say to include units of measure. The amount was measured in pounds, and the x's were measured in days. So pounds per day would work, okay? And that was worth just 1 point. You had to have your answer and your units to do that. All right, part B, find the value of A prime of 15. Using correct units, interpret the meaning of the value in the context of the problem. Well, A prime of 15, all we need to do on this one is just use math 8 because we're finding a derivative. So we are just going to find A prime of 15, and when we do that, we're going to get negative 0.164. And then it says, and that's worth 1 point, and then it says to interpret this in the context of the problem, and I'm just going to write the amount of grass clippings, and we decide, is it increasing or decreasing? The amount is decreasing because our derivative is negative, is decreasing at a rate of 0.164, and this was measured in, if we remember, the derivative would be measured in pounds per day. And then when was that at? It was at t equals 15. So we do want to include all of that information in order to get our point. And you could say it a little bit differently, but that's basically what we should have. Okay, for part C, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. Okay, so I've got this equal sign, so I know I'm going to be setting two things equal to each other. I'm going to set the amount of grass clippings in the bin, which is given by A of t, and I'm going to set it equal to the average amount of grass clippings. Well, I know if I see the word average, it's going to be 1 over b minus a, so it'll be 1 over 30, and then the integral from 0 to 30, and it's the average amount again, so the amount. Okay, so that's the formula that we want to have set up, and what we're going to be doing is solving this for t. And when I do that, the amount of grass clippings, just a second here, I want to get an answer here. The amount of grass clippings, when I find that average, this is going to equal 2.753. So I want to find out when will that amount equal that. So the amount formula was 6.687 times 0.931 to the t is equal to 2.753. And then I'm going to subtract 2.753. So I'll get something that looks like this, well, minus 2.753 equals 0, because if it's set equal to 0, then I can use the 0 feature of my calculator, and when I use the 0 feature of my calculator, I'll get t equals 12.413 days. All right, and that problem would have been worth 2 points. I would have gotten 1 point for setting up my equation, and then 1 point for actually getting the right answer on that one. Okay, for part D, for t greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Show the work that leads to your answer. Well, first of all, a linear approximation is just an equation of a tangent line. So we won't be afraid when we see that. That's all that it means. So we want y equals mx plus b. Okay, the slope, we're talking about the linear approximation to A, so the slope would just be the derivative of the amount, and that's going to be happening at t equals 30. So we'll be finding A prime of 30, and if you find A prime of 30, it is equal to negative 0.056. All right, and then we know our x value is 30 because it's at time equals 30. And then to get the y value, we're going to plug 30 into our original equation, so we're going to be finding a of 30. And when we do that, we'll get 0.783. So finding my b, I'll get 0.783 is equal to negative 0.056 times 30 plus b. And then I'll get 0.783 is equal to negative 1.68 plus b. I'll add 1.68 to both sides, and that will give me a b value of 2.463. So the equation of my tangent line is y equals negative 0.056x plus 2.463. But we're not dealing with y's and x's, we're dealing with L and t, so I am going to change that. So I'll get L of t equals negative 0.056t plus 2.463. Okay, so it says to use that tangent line. So I found the tangent line. Now use it to predict when there will be 0.5 pounds of grass in the bin. So L of t would be how much grass is in the bin. So I'll just set 0.5 equal to negative 0.056t plus 2.463. I will subtract 2.463 from both sides. And when I do that, I'll get negative 1.963 is equal to negative 0.056t. And then if I divide both sides by negative 0.056, I should get 35.054 days. All right, this problem was worth 4 points. We get 2 points for getting this part right here. I'm guessing we'd get 1 point for finding the slope and then 1 point for finding the b. And then we'll get 1 point for setting that equation equal to 0.5. So we've gotten 1 point right there, and then 1 point for getting the right answer.